Welcome to show number 260 of the Arc Junkies podcast. Joining me today is Jerome Spear from J.E. Spear Consulting. Jerome is an industrial hygienist and has been in the industry for almost 3 decades. If you don't know what an industrial hygienist is, don't worry, you will by the end of the episode. I thought I knew what an industrial hygienist was, but I only knew a small portion of what they actually do. I've been wanting to get this episode out for over a year, and it turns out industrial hygiene is a pretty niche industry. It took me a while to track someone down to come on the show. My main reason to have an industrial hygienist on the show was to discuss welding fumes, the potential hazards they pose, and how to best mitigate exposure for welders in the shop as well as in the field. We do a bit of a deep dive in one specific compound that I wanted to raise awareness to, and that is hexavalent chromium, which is primarily found when cutting and welding stainless steel. We discuss some of the other hazards as well. You all may or may not know the mission of the Arc Junkies podcast by now, but just in case you don't, the mission is to help, educate, and inspire the next generation of welders. And I'm hoping this episode helps to bring awareness to some of the potential hazards we have to deal with as welders, educates you all on the best way to protect yourself while performing the work, and inspires you to take precautions to mitigate risks. We'll get right into the show after a quick word from the folks that keep the lights on in the BuzzBox studio. Today's episode of the Arc Junkies podcast is brought to you by Outlaw Leather. You all know them for their badass custom hoods that they build, but that's not all they carry. Outlaw's teamed up with Up and Smoke Welding Apparel to offer their Zestos shirt, which is available in an FR and a non-FR version. And if you prefer sleeves over a jacket, they're now carrying the Up and Smoke sleeves as well. And for the ladies, Outlaw recently collaborated with Stephanie Hoffman from Underground Metalworks to release a new women's welding jacket to provide you with the best protection and the best fit when it comes to your gear. Outlaw also carries all the hand tools, safety gear, and fit-up tools you need as a welder. Check out their website at outlawleather.com to get tooled up. Outlaw offers fast, easy shipping so you can get exactly what you need when you need it. And as a special thank you to the listeners of the Arc Junkies podcast, you can get 15% off all their in-stock handmade leather goods when you use Arc Junkies at checkout. And if you'd rather shop in person, stop by their store in Pasadena and tell them the Arc Junkies sent you. We're also brought to you by Rockmount Research and Alloys. Are you a maintenance welder, heavy equipment mechanic, or an industrial maintenance technician? Do you commonly face the same repairs in your facility or out in the field? Then you should check out Rockmount Research and Alloys. Rockmount's maintenance welding products are specifically designed to perform in the toughest, most unpredictable conditions. Rockmount's maintenance welding products are specifically designed to perform in the toughest, most unpredictable conditions. Their rods and wires help you to reduce re-welds and keep your equipment up and running, saving you time and money and giving you the space to tackle your next challenge. We all know if your welding equipment is down, it's costing you money. Keep your equipment in the game by getting the job done right the first time, every time with Rockmount. And right now, listeners of the Arc Junkies podcast can save 10% off Rockmount's burrs, bits, blades, abrasives, and welding chemicals when you go to rockmountwelding.com and use Arc Junkies at checkout. Get the job done right the first time, every time with Rockmount. All right, you know what time it is. Fire up your machine, drop your hood, and turn me up 5.
You're listening to the Arc Junkies podcast, helping you make every weld better than your last with each episode. And now your host, Jason Becker.
All right, joining me today is Jerome Spear with J.E. Spear Consulting. I'm assuming you own the company. Is that correct?
Yes, that's correct.
Okay.
Yeah, since 2004.
And you're an industrial hygienist, and it's a topic I've been wanting to talk about on the podcast for a long time because, like, we chatted briefly before the show. Not a lot of people know what an industrial hygienist is or what they do. So if you can tell me a little bit about your background and then what an industrial hygienist actually does. Right.
Industrial hygiene is a rather old term. It's been the field's been around since the early 1900s, 1930s, or even before. And it's not a very descriptive term, so I understand, just by hearing the term, you usually have to describe what it means. But the classic definition is the anticipation, recognition, evaluation, and control of occupational environmental health hazards. And those hazards can be chemical in nature, such as welding fumes, lead, organic vapors, asbestos, gases. They could be physical in nature, such as heat stresses, thermal stresses, cold stress, radiation, both ionizing and non-ionizing radiation. Noise is an example of physical agent, and biological agents, such as fungal fungi, bacteria, bloodborne pathogens as well. So that's what industrial hygiene is. And I've been in the field pretty much my whole career, 30 plus years, been certified since 1998.
How did you get into industrial hygiene?
Well, I went to school at Texas A&M, and like I would say most incoming college students, they didn't know what the heck they wanted to do, and I was one of them. I thought I wanted to be something in related to computer science field, and I took my first computer science course, and everyone seemed to be talking Greek to me, and I said, this is not for me. I didn't know anything about Fortran or any of these other programming languages, and so I started looking for another degree and started looking at the types of subjects that engineering, different engineering disciplines. So I knew I wanted to be something related to engineering, some type of engineering field, and I started looking at the safety engineering program and started recognizing that there's a wide diverse topics. And I'm the type of person, if I stay in one place, I get bored too easily, and I want to move on. And so I spend a lot of my time in construction. That's why I like consulting, because every day is different. Essentially, I'm not at the same site every day. I'm not doing the same thing every day. Um, so it encompasses a little bit of everything. And I started asking around different advisors and folks about this field, and I found out that there was a need. It was in high demand, so that was another factor. I want something that's practical when I get out, that I can get a job, and that was key. I mean, and looking back, I kind of fell into it. I mean, it kind of fits my personality. I'm very detailed oriented, analytical. As I got hired, I hired on with Chicago Bridge and Iron Company, and some of your audience may know who that is. I spent quite a few years with them, and then we pretty much were given responsibility to do industrial hygiene work. We had worker safety, but also industrial hygiene. So we didn't have a corporate industrial hygienist, maybe for a period of time, but just a brief period of time. And so that fell onto the shoulders of the different safety engineers, safety managers, and so forth.
Yeah, and I got to admit, I always thought an industrial hygienist was just somebody that came in and collected air samples and just, kind of gave the information back. I didn't know that there was so much involved in the process of industrial hygiene. But I mean, like going through some of your articles on your website, I mean, you pretty much cover everything as it relates to, hazard identification, hazard mitigation on the job site or in the workplace when it comes, well, especially to construction. I mean, that's kind of like where my audience comes from. I mean, so they'll understand that. But I mean, yeah, I always thought it was just collecting air samples, and like I said, as going through your website, I was like, man, there's really a lot more to this. There's risk assessment and a lot of analytics that go into it, and study and mitigation factors that all result to some of the standards that we're held to today.
Yeah, that's right. I mean, I would say for the practicing industrial hygienist, evaluating the hazards is we spend probably the most time doing that. But it starts with recognizing and anticipating what the exposure is. It's hard to go out and collect, air sampling if we don't know what we're looking for. So we have to understand what we're looking for, and we have to also understand what the risk is. And use that term risk, and that's part of the role of industrial hygienist, is to assess what the risk is. And the risk, think of it as the potential hazard or health effects, such as something that's irreversible, causes irreversible damage to lung cancer. Well, that has a potential high health effects, right? And then the other component would be the exposure level. So the higher the exposure level, the higher the potential health effects, you have a higher risk. Okay, those are the two components. So that is what we do. We're not medical doctors, but we do have a certain amount of training in toxicology, so we can evaluate the risk. We can understand what the risk is. When I'm involved in litigation cases, then I don't give causation opinions, but I will opine about, does it significantly increase the person's risk? Okay, once it enters the person's body, then that becomes a medical issue, and that's outside my expertise. Now, industrial hygiene deals with how someone can get exposed. It's part of recognizing the hazards, how someone can expose, the pathway to exposure, and the receptor. And then the engineering controls also pertain to that as well. First, critical factor is to substitute out the hazard. That's a priority. Something that's less hazardous, or just eliminate the hazard all, completely if we can. If we can't, then we implement feasible engineering controls such as local exhaust ventilation, administrative controls such as procedures, training, warnings, air monitoring, and then personal protective equipment is the least effective means of control. Sometimes it's necessary to supplement, the engineering controls, but it is the least effective means, and we try to do these other things first.
Really? Now that's kind of odd, just for the simple fact that like that's when you're out on a job site, you're in a shop or whatever. I mean, that's what they beat into your head is PPE, PPE, and a lot of times they don't take the aforementioned engineering controls into consideration. Like the company doesn't really do anything to mitigate the risk. So your PPE, that's like your primary source of protection in a lot of cases in our industry.
It is, and that's not the way it's supposed to be. In fact, OSHA standards, such as the Chrome 6 standard and some their other health-based standards, they do require if you're above if the exposure is above the PEL, the permissible exposure limit, then OSHA does require that the employer implement feasible engineering controls to reduce the exposure below the PEL, and then they do allow respiratory protection such as respirators, to supplement as an interim protection or to supplement the engineering controls. If the engineering controls are not effective reducing exposures below the PEL, then you supplement it with respiratory protection. So it's actually written in the OSHA standards that way as well.
And that's the main reason I wanted to get you on the podcast, but I also want to talk about some other stuff later on, is hexavalent chromium, because I've mentioned it several times on the podcast before. A lot of people in this industry, they work on stainless steel. And they do beautiful work, all kinds of different processes, whether it's shielded metal arc welding, gas tungsten, gas metal arc welding, but they're all welded on stainless steel. And that is a particular type of metal that's rather toxic to weld on because of hexavalent chrome.
Well, that's true, and I was telling you before that early on in my career, I spent pretty much my whole career involved in welding in some form or fashion. As a field engineer for CBI, between jobs, I would come back into the welding school and learn how to weld. Spend several weeks there, welding all day and taking welding tests, and learn to appreciate how hard it is and difficult it is to weld. To be a good welder, I was able to pass the test, but just barely. And out on the job sites, I would do some tack welding and fit up, but I was not a certified welder. But I did have, over the years, I worked around some very good welders, and learned that it's both an art and a skill, and I have an appreciation for the trade, and I encourage people that people I come across who's looking for a trade to go into welding or look at welding anyway, if that's an interest, because there's a demand for welders still, and it takes a skill. It is a skilled craft. Quickly in my field, I learned that there's a most industrial hygienists did not understand welding, and it wasn't until OSHA's Chrome 6 standard was promulgated in 2006, that we started training our industry or profession more about welding and the welding processes, so they can understand how Chrome 6 is emitted. It's Chrome 6 is not in stainless steel, not in hexavalent chromium steel. You got a high level of chromium content in chromium alloy steel, such as stainless steel, somewhere around 20 to 30%, chromium by weight. But when you heat it up above its melting temperature, then it emits chromium oxides, and some of those are Chrome 6. And different welding processes obviously have different fume generation rates, but even when it comes to hexavalent chromium, certain welding processes have more of a concentration of Chrome 6 in the fumes, such as stick welding fumes. Or shielded metal arc fumes tends to have a higher concentration of Chrome 6 in the fumes itself, and so we tend to get high exposures if somebody's doing any substantial stick welding involving stainless steel. Even though stick welding has a lower arc time, typically as compared to MIG welding or flux core arc welding, generally we end up having higher exposures to those who are stick welding.
Yeah, I was surprised to find out that it's actually you're getting more exposure from the filler metals. and the fluxes that you're using than the base metal typically.
Yeah, typically 95% of the fumes originate from the consumable. That's correct.
And now, what are some of the dangers of hexavalent chromium or CR6? I mean, it's a couple different words that describe that property, but I mean, like, what are some of the dangers that are inherently, revolve around that toxin?
Well, hexavalent chromium is a confirmed human carcinogen, causes lung cancer. The potency of it depends on the actual compound. I mean, some forms of Chrome 6 compounds, hexavalent chromium compounds, and there's, the Chrome 6 from Welding fumes is just one of the many Chrome 6. Now, OSHA regulated standard, all forms of Chrome 6 equally, essentially, but it covers a different industries such as chrome plating, the coatings industries, the pigment manufacturers, but the workers affected by the standard, roughly half or more were welders. So that's why there was an interest in my profession to understand welding, and there was more presentations, more training, more educational programs presented revolving welding and Chrome 6. So Chrome 6 can also cause dermatitis in some forms, such as the chromic acid in chrome plating. So you have more soluble types of chromium 6 compounds, which when I say more soluble, meaning it's more of an irritant. Meaning that it's more soluble in water, so it's more soluble in our body fluids because most of our body is made up of water. So it's going to have more of an irritating effect. It can cause dermatitis. It can cause skin ulcers, not typically in welders, but in other industries, it can cause a perforation of your septum, which is the tissue between the nostrils. But again, that's not typical in typical welding operations. Those are for different industries, such as chromic acid or chrome plating, the chrome plating industry.
And that's one of the things, because like I got out of I got out of doing structural steel ironwork and got into education. But before, while I was out there on the job site, we were told, hey, if you guys do anything with stainless steel from now on, you have to wear a respirator. And we're like, okay, what changed? Nothing. Just put your respirator on anytime you're working with stainless steel. They never gave us a reason. They never told us about hexavalent chromium. They just said, anytime you're welding stainless, here's what you got to do. And that was like the only barrier between us and the weld fumes. There was no, like I said, PPE was our primary source of protection versus, putting it in engineering barriers in between us and the fumes. So we didn't have fume extraction. We did, the only thing we really had was like you could turn on the fan and that would blow fumes away. But you'd have to turn the fan off when you go to weld because you don't want it to blow your gas away. So it's like a catch-22. So our primary source of protection was the respirator, and they wouldn't tell us why. And it wasn't until I got into education and started doing some research that I was like, oh man, there's some nasty stuff inside stainless steel. Anytime we cut on it or weld on it, and at one point I thought grinding was also something that could release the hexavalent chromium. But after reading your articles, I'm not so sure that that's the case anymore. But that was like our primary source was wearing a respirator, and they never told us why. But now that I dive deeper into it, I understand why, and that's kind of why I want to get the information across to all the listeners and say, hey, if you're working with this stuff and your company's not protecting you, go ahead and protect yourself.
Yeah, there are some situations where that is the protection that you need because as far as risk for protection, because it's not feasible to use a local exhaust ventilation. I can explain a couple of different types, and it's more simpler than what it may sound like a fume extraction system. I can discuss some of those as well. But for instance, when you are using a portable fume extractor, so you have a filtration unit, it's got a duct and it's got a hood on it that's movable. Someone who's welding the width of a plate using flux core arc welding, they're not going to break the arc to readjust the hood, and I realize that. And once you get beyond a couple inches beyond the outside of that hood, is that the capture efficiency is not very good as well, and I can show you videos of that as well. So in that situation, if somebody's welding the width of a plate and in a down flat position, I can tell you after they would need to break the arc every foot or so to readjust the hood. And that's not going to happen. They're going to weld it with the plate, which, say it's an 8 foot, 8 to 10 foot wide plate, without breaking the arc typically. So there, I would say, and I told clients it's not feasible to expect them to do that. So they need to be wearing a PAPR. This is stainless steel. So I would expect the exposure to be more than 10 times the PEL for that operation. In those situations, they may be welding a vessel that's on rollers in the shop that's positioned horizontally, and so they're laying in a prone position, and they're not moving. The vessel around them is moving as they continue to maintain welding in a down flat position. So there's no way we can get a fume extractor in there to position there while the vessel's moving around them. So in that situation, same thing. You would have to wear PAPR, which is the power air purifying respirator. It has a higher protection factor. And I know many of your viewers probably wore PAPRs before.
Yeah, I'm sure. Like PAPR systems are becoming a lot more prevalent in the industry. Thank God.
Right. Now you mentioned something about the fan and stuff like that, and that's right. What I find with people, and this is really a tough time to educate even supervisors and welders about positioning a fan is not going to be effective. That's blowing. I mean, you have to exhaust it, and it has to be very close to the welding zone, but pulling the fumes instead of pushing the fumes away. What happens is that they position the fan, the pedestal fan, say, behind them, and so the air comes around their body and it competes with each other and causes a swirling motion like a vortex. And that keeps the fumes in their breathing zone for a longer period of time instead of it would be better off not to have a fan at all blowing and let the natural currents carry the fumes away. Now it's unreliable as far as, the currents may blow the fumes back towards the person's breathing zone, or sometimes they may blow it away from them. The ideal situation would be to get a fan. Doesn't have to be a fume extractor. Could be a pedestal fan, position it close, about a foot away from the welding zone, and exhausting the fumes. So it's pointing up and exhausting fumes out, up and away from the welder. And you can visually see the fumes being pulled in the fan away and not being directed away from the welder and being pulled into the fan and then dispersed. And it's a very crude but very effective method, and doesn't create an exposure issue for people in the area as well, because it rapidly disperses the fumes.
Okay, so if you're a welder in a shop, they don't have mechanical ventilation set up, you don't have access to a respirator or PAPR system, set your fan up backwards and have it pull the fumes away from you and blow it elsewhere.
Right. And so, I mean, the ideal is that the capture velocity needs to be between 100 to 200 feet per minute. That's low enough where it's about 1 to 2 miles per hour. That's low enough where it's not going to move the or blow away the shielding gas. And you can visually, same thing. The good thing about welding fumes is you can visually see which direction the fumes are going, and if it's working or not. That's correct.
No, it's really, I've never thought about setting up the fan backwards. Well, because I'm down here in Florida and you're out in Texas, I want that fan blowing on me a little bit.
Yeah, well, it gets hot down here too. Actually, I actually learned that trick from a client of mine, and they're welders. So when you give them a problem, they're very good at solving the problem. And you say, well, you gotta use this device or come up with some other different way that works, and that and that's what they do, and they're very good at coming up with solutions.
Oh yeah, welders are pretty crafty people.
Yeah.
So not just with stainless steel, but there's other metals and stuff that we work with as welders that are just as potentially dangerous. One of them being anything with a galvanized coating. So a lot of people, they'll weld over galvanized, or they'll grind the galvanized off and then they'll weld on it. And like the biggest misconception, the biggest myth that I've heard is, oh, drink milk. And that's supposed to stop the effects, but that's not the case. And like from what I understand, milk only masks the symptoms. I don't know if you can speak on that, if working with galvanized inside your wheelhouse, but that's one thing that I'd really like to put to bed is like, that's what I was told. I went out to do a firehouse with a group of guys one time. All the steel going inside the building was galvanized. They said, don't grind any of it off. Just, burn it hot, weld it in. And before we got there, the boss man stopped at the gas station. Everybody bought a quart of milk. They told me to buy one. We drank that every day on the way to the job site, and that was like
Mhm.
supposed to protect us from galvanized. Now, what's
Yeah.
your experience with with that
Well,
coating?
as an industrial hygienist, that I don't, that's outside my realm of expertise of whether or not milk is effective. I heard that over the years as well. I don't know if that's true, if it actually works or not. It's not something I advise because that becomes more of a medical, recommendation, and I'm not a medical doctor.
Hmm.
But welding on galvanized, and what the actual exposure is, you're being exposed to zinc oxide. The zinc in the galvanized is what protects the steel, and so it creates an acute exposure, acute effect of metal fume fever, which is flu-like symptoms. So you recover from it. It's not, it's reversible. It's like, and you do build up a tolerance to it, my understanding, but you lose that tolerance over the course of a day or two of not being exposed also. But um, and so yeah, any coatings, if there's any coatings at all, um, you need to stop and say what is on this metal, what can I be exposed to, because you can expect that whatever coating is on there is going to be in fumes. There's going to be metals on the coating, whether it be arsenic, cadmium, lead, chromium. It could be another source of chrome six, or if it's galvanized, it's definitely going to be zinc oxide. You're going to oxidize the metals, and you're going to create an exposure to it. So you likely will need to have some form of local exhaust ventilation, or depending on the hazard, if it's a lead job, if it has a lead-based paint on it or coating on it, then we'll probably have to remove it through engineering means, through chemical stripping or vacuum blasting or vacuum tooling or something of that nature. Um, so it depends on the hazards. If there's a coating there, you got to stop and think and say, what is on the coating?
Yeah, that was one of the big things we did down here. Especially working at the theme parks. A lot of the stuff that was painted at the theme parks is lead based paint because of
Mhm.
how old the structures are or whatever. So every time we went out to go do a job, we'd have to get a report whether that area needs to be abated or not. So they'd have to come out there and they'd have to collect samples of the paint. And this could be like a 2 or 3 day process, but they'd have a team go out there and they'd scrape some samples off or pull some samples off or whatever, and then they'd have to go back to the lab, test it, and then they'd send us a report letting us know if it was lead based paint or not. And if it was, then we'd have to get that like an area around where we're going to be welding completely abated. So I think they had to
Yeah.
stay like 4 or 5 inches outside of the welding zone. So we had to be very specific where we were making our repairs or making our connections because I guess they charge by the square inch and it's pretty
Yeah.
expensive to get that stuff abated.
Yeah. You have to move if it's a lead job. You have to remove it. At least 4 to 6 inches on each side of the cut line before you start doing any hot work on it. So that's a serious. I mean, there's of course an OSHA standard for lead. There's a lead compliance program would be required on a job like that, and what you have to detail your engineering controls you're going to use, what methods you're going to use, and air sampling and evaluations and protection. What your regulated area would be have to be established. You have to have hygiene facilities, protect the clothing. So a lot of things. I mean, there will be even more requirements than there are for that welders have to use than as compared to the Chrome 6 standard. Now there are provisions in the Chrome 6 standard that requires protective clothing, but that's if there's a recognized skin or eye hazard, then you have to have protective clothing. And whenever you require protective clothing, then you have to have change facilities and wash facilities, hygiene facilities to remove the clothing and wash up and so forth. Um, the reason why welders do not are not required to wear protective clothing when dealing with or welding on stainless steel is because for typical welding operations, the skin and eye hazards are considered to be minute. And OSHA states that in their preamble, and that's my personal experience. I'm not aware of, you may experience it, but it would be a really rare occasion if somebody actually experienced some type of skin ulcers or skin condition or or eye irritation or eye condition, or as a result of welding stainless steel. I haven't really seen it. So in my profession, but that's why welders don't or not. It's not necessary to wear protective clothing, have hygiene facilities when welding stainless steel, like you would if it was a lead job.
Okay. Now with stainless and everything, when you cut that with, let's say, plasma cutting, or you're doing like an excessive amount of grinding or polishing, would it be advisable to wear protective clothing at that point, or do we also need to wear a respirator or PAPR if we don't have access to mechanical means?
Well, grinding, like you alluded to earlier, it's you should not emit Chrome 6 from grinding.
Because the
Now, a lot of
temperature,
time,
right?
because you don't get it to you don't get it to a temperature that's above its melting temperature. Now you may do some air monitoring on the grinder, and he comes back with some level of Chrome 6. That's probably because he's also around some welding operations. Would be what I suspect that would be the case. Now, for plasma arc cutting, you definitely do have Chrome 6 being emitted. Most of the fumes are going to be emitted on the back side, on the opposite side of the plate from the operator. It is a high fuming process as well. You can see the fumes, but if you do plasma arc cutting in the shop, and you see most of the fumes are being emitted on the bottom side of the plate, underneath the side of the plate. But you should do some. A good thing about arc gouging or plasma arc cutting, you don't have to worry about blowing away the shielding gas. So you can go ahead and put up as many fans you want, and dilute as much as you can. You can direct the fans directly towards the plasma arc cutting operator and the arc gouger. And so, you can kind of just move as much air as you can. So instead of trying to exhaust it, because you also have, when you use local exhaust ventilation, you have to try to get rid of as much opposing air currents as you can, because it's a lot harder to suck air than it is to blow air, and you can only suck air so far. Pull air from such a distance. And so with arc gouging, you have air that's competing air. So using local exhaust ventilation, like a fume extraction hood, is going to be not going to be very effective, because you have this air that's being blown out from the arc gouger. So that's a competing and opposing air current that the local exhaust ventilation, the capture hood, has to overcome.
Okay. And then with the grinding, it's not so much a concern. I mean, you're going to want to wear something anyway, just so you're not breathing in particulate, but you don't have to worry about hexavalent chromium.
Grinding is dusty. I mean, it's larger particles, and typically, depending on the type of metal that you're welding, with the exception like grinding aluminum, you can get some very fine particles, but typically grinding dust, grinding alloy steel, and carbon steel, you're talking about larger particles. Most of it, but you get dust all over you. I mean, most people will wear a face mask, an N95 filtering face piece respirator, if they're going to be grinding all day. And I've done that all day. It's
sucks, doesn't it?
It's tiresome. Yeah, you
Maybe
get tired
the welder
holding
I
up a
am
grinder
today.
all day. Yeah, and you get dusty. Get dust down your shirt and stuff. And you're stuck to your sweat. So, and same thing, with grinding, local exhaust ventilation is not going to be effective for grinding as well, because your particles are propelling at such a fast speed off the grinding wheel, off the surface, that the capture hood is not going to collect the majority of those particles.
So, yeah, I mean, like ideally, what you would want from like a business owner's perspective, if you're running or operating shop, or maybe even a supervisory position with, you got access to budgetary funds, setting up a downdraft table for a lot of these operations would probably be ideal. Because like you said, at the source fume extraction is probably not going to be the best bet, just because you can't get that entire surface area that you're grinding or plasma cutting on into that snorkel per se.
Mm-hmm.
But over a downdraft table or something, you'll be able to pull all that fume down, which is the direction it's traveling anyway. Same thing with the particulate matter.
Yeah, if you're doing plasma arc cutting, because like I said, most of the fumes being emitted from the opposite side of the plate. What's even more effective would be a water table. Drown trap tables depends. I mean, if they're not you have the filtration issues that you have. Anytime you have the filtration issue, removing particles by filtration or other electrostatic precipitators, it requires a lot of maintenance to clean those out regularly, and a lot of times that doesn't get done frequent enough.
Yeah, there's no
But
time for maintenance in welding.
yeah, but and so sometimes I see a downdraft table, I can see the fumes coming back up, and so but with a water table, it's very effective at knocking the fumes down. I mean, just part of the plate is touching the water, and you're knocking down all the fumes, so it's very effective.
Okay, but you can't do water tables with aluminum because I guess when you cut aluminum with plasma, somehow it generates hydrogen. And so that can create an air pocket between the material and the water. And then once you cut over that air pocket, well, not air pocket, like a hydrogen pocket, it'll explode.
Yeah, you're right about that.
So you got to be careful with that too.
Yeah, I'm used to dealing with mostly carbon steel and stainless steels and
Yeah,
alloy steels like that.
aluminum's kind of a different animal. I mean,
It's different.
and I guess with aluminum, I don't know how true it is. It's just speculation stuff I've heard from like people in the industry. When you're cutting, grinding, and welding on aluminum instead of hexavalent chromium, your whatever it releases can be linked to like Alzheimer's and dementia. Do you know if is there a correlation between that, between Alzheimer's, dementia, and welding and working with aluminum?
Yes, I mean the threshold limit value, which is a kind of like a PEL, but it's recommended by the American Conference of Governmental Industrial Hygienists, ACGIH. Their TLV for aluminum is based on a respirable fraction, meaning particles that can be respirable, typically less than 10 microns in size. And their respirable TLV is at 1 milligrams per cubic meter, and that is based on neurological orders. Is for the same reasons you mentioned. It's neurological disorders. And the thing about aluminum, it's more volatile too as compared to the other metals that we're used to dealing with. So that's why I say with grinding on aluminum, you can generate respirable size particles because it's more volatile. Welding aluminum, you're going to generate more fumes because it's more volatile. And by the way, you can have some chrome 6 exposure from welding aluminum based on the consumable. I don't have much experience with that, but I read articles on it. I don't believe you're going to be above the action level typically, but it's something that should be looked at. If you're welding aluminum, also look for chrome 6.
Okay. Now you mentioned PEL, which is permissible exposure limits, and then what was the other one? Threshold
Limit values, which is
TLVs?
recommended by the TLVs recommended by ACGIH. And there's also recommended exposure limits, which is recommended by the National Institute of Occupational Safety and Health, which is when OSHA was promulgated in 1970, NIOSH was also established, which their role is to conduct research and recommend standards to OSHA.
Gotcha. So with permissible exposure limits, that's essentially saying what you can be exposed to in an 8-hour time period, correct?
Depends on the agent. If you're talking about chrome 6, yes, it's based on an 8-hour time weighted average, which is TWA exposure period. But if you're talking about something that has acute effects, then you may have a short-term exposure limit that's based on the 15 or 30-minute exposure period, or we may have a ceiling limit, which shouldn't be exceeded for any length of time. So it depends on the agent. So it's something that has acute effects or immediately dangerous life and health, then you may have a short-term exposure limit or a ceiling limit, such as carbon monoxide. This person can die at a certain level. Now, carbon monoxide also has an 8-hour time-weighted average exposure value, which is based on hypoxic stress. As you're exposed to lower levels of carbon monoxide, then your body has to work harder. So somebody who has an existing heart condition may be at an increased risk of a pulmonary condition or heart condition, heart attack or something like that. It just increases their stress. So, and carbon monoxide, I mean, that's, welding does generate a certain amount of carbon monoxide. It's typically not an issue unless you're in a confined space. and you typically not just from welding, you're likely not going to get it at a level that's immediately dangerous to life and health. For CO, you may get above in a confined space. May get above, if you're arc gouging with little ventilation, you may get levels above the 8-hour time weighted average that increases your body stress level. But welding, carbon monoxide is formed by incomplete combustion, and welding is a combustion process. So you're going to have a certain amount of carbon monoxide generated.
And that makes sense. I've never thought of it that way. So with a permissible exposure limit, it's like a time frame, but like with the threshold values, that's over the course of your life, correct?
No, the threshold limit values are the same thing. They're based on an 8-hour time weighted average.
Okay, so that's
they're
what I was wondering.
based
If
yeah.
you worked with aluminum for X amount of years and you had this exposure, it's just constantly building up inside your central nervous system.
Okay, now you're talking about dose. Okay, and I do some dose calculations on occasions. Typically, it's in the context of litigation, but dose is the average 8-hour time weighted average exposure period during the course of a year times the number of years exposed. So somebody on average is exposed to 1 milligrams per cubic meter of Chrome 6 per day over the course as an average exposure, and they're exposed to that for 40 years. Their dose would be 40 times 1 milligrams per cubic meter. So it'd be 40 milligrams per cubic meter years. So so what you're describing is dose, and that's an important calculation, especially something that has cumulative effects such as welding fumes and asbestos and various different other contaminants that have cumulative effects.
Yeah, if you're working with this stuff for a number, I mean, like you could probably get away with doing it, tinkering around here in your garage, there, here and there. But if you're out there doing this day in and day out for an entire career, you've got to check, like, you have to understand these effects of not protecting yourself. Take precautions today so you can prevent things tomorrow.
Right. And like I said, Chrome 6, there's different forms of Chrome 6, and in the studies, as it pertains to welders, is somewhat inconclusive as far as how potent it is as far as causing cancer. I know there's studies that compared mild steel welders to the stainless steel welders, and they found no substantial difference in the risk of lung cancer. Now, part of the problem is trying to parse out those who are exposed, those who only weld stainless steel and those who only weld mild steel or carbon steel, and also those who are exposed to asbestos, which is a known lung carcinogen, and those who aren't exposed to asbestos. You typically have mixed exposures, and in doing epidemiology studies, it's very difficult to parse out those confounding variables.
It's hard to nail down what put the final nail in the coffin.
Yeah.
Okay. Yeah, because you got so many different exposures, especially in this career. Like you said, asbestos, lead, stainless, regular carbon steel. Because carbon steel release manganese, right? When you're welding on that, you get exposed to manganese fumes.
Right. Yeah. And I have an article on my website on manganese, and as well. I don't know if you had time to look at that, but with manganese has a very low TLV, threshold limit value, and again, that's a recommended value, and it's based on respirable fractions. It's 0.02 milligrams per cubic meter. It's very low value. Most typical welding operations involving flux core arc welding, stick welding, MIG welding, you're going to be over that number really quick. Vast majority of the times. Yeah. I mean, it's not going to take much to get over that number. Now that TLV is based on preclinical effects. Now, manganese does cause neurological disorders similar to body tremors, such as Parkinson's-like disorders. It's called manganism. But it causes body tremors, is what it's believed to cause. But it causes neurological disorders. But this low TLV is based on preclinical effects, meaning you may have reduced motor skills or reduced reaction times. So it's and I put that out there. I reference my paper when I do air sampling studies involving carbon steel, because most cases they're going to be above that number unless they use some type of local results ventilation. I do recommend using local results ventilation when feasible, and if it's not feasible, then supplement it with restorative protection. But I also want to give the client the complete information. Okay, it's based on preclinical effects, and they should inform the welders who are representative of having this exposure, should inform them of the results of the studies, or the results, sampling results. Now, OSHA has a PEL, which is a sealing limit for manganese, which is not going to be exceeded. The sealing limit is 5 milligrams per cubic meter. It's very high. It won't even come close. I mean, typically, I would say typical welding operations, you're looking at exposures for manganese, anywhere from 0.05 to 0.5 up to 0.5 typically. Very easy to even get 10 times the threshold limit value, which is the assigned protection factor of a half mass respirator is 10. You have to go to something else like a PAPR. It has higher protection. That's why I suggest local exhaust ventilation where feasible. Use some crude methods as far as using an exhaust fan. Doesn't have to have a filtration system. Doesn't have to be one of these $5,000 units. It can be something that you have on the shop floor that you can help move the fumes away from the welder's breathing zone. Now, thing about manganese is typically it has a small amount of manganese in the rod, which increases its hardness and its properties, but it's enriched in a fume, meaning that it has a higher concentration in the fume than it does in the metal, in the electrode itself. So say it has 1 to 2% manganese in the wire, the fume is going to have somewhere around 6 to 12% manganese in the fume.
Damn.
And the reason for that is because it's more volatile. It's like aluminum. It's compared to the other metals present in the consumable. It's more volatile, so it's going to be more rapidly vaporized, if you will, or turn into its gaseous phase, and then
because it's doing a phase change. It's going from a solid state to a vaporized state or gaseous state.
Yeah, and then it goes back into a solid state in the form of a fume. So it's a rapid cooling of molten metal that creates the fume off the metal, which is a solid particulate. So it's a very fine particulate. You're talking about sub-micron size particles. Now, 1 micron is 1/1,000,000th of a meter, which is so small you can't see. Now, collectively, if you have a bunch of particles together, it's like an ant pile. You can visibly see the plume. So you can just see how many particles that's in this fume, because you can visibly see it. But because you can visibly see it, you can see that you can do a qualitative assessment, but visually see which way is it moving. Now, the welder who's welding can't do that. Somebody else will have to observe it. Which way is it, or the fumes moving, in relation to his breathing zone. The ideal is that we don't want it to be in the welder's breathing zone. We want to minimize the amount of fumes that's in his breathing zone. So we want to pull it away from his breathing zone as much as possible.
All right, we're going to go ahead and take a quick commercial break. This segment of the Arc Junkies podcast is brought to you by Strong Hand Tools, makers of my favorite welding tables and fabrication tools. And right now, listeners of the Arc Junkies podcast can save 10% on select Strong Hand tables and 5% on all their tool packs when you go to stronghandtools.com/promo. Strong Hand has the tools and tables to help you increase your speed and accuracy on all your builds. So check them out today at stronghandtools.com/promo. We're also brought to you by Everlast Welders. They just released the all-new Typhoon. It's a badass stick and TIG machine packed full of advanced features and functions, including all new industry-first waveforms. The Typhoon is available in a 230 amp or a 325 amp version. Both feature a 7-inch high-def colored user interface screen, AC/DC TIG and stick capabilities, pulse adjustment, and 5 AC waveforms. The Typhoon is available right now for pre-orders at everlastwelders.com. And as always, be sure to use Arc Junkies in the comment section at checkout to get that free Nova foot pedal and TIG torch when you buy any machine that comes with a stock foot pedal. Everlast Welders. Weld mean, weld green. Now let's get back into the show. Yeah, it's kind of. I like the visual. I don't know if you've ever seen it. Lincoln Electric put out a like a fume safety video, and it was a essentially an keep your head out of the alligator's mouth. So the fume plume is like the head, the alligator's mouth. You want to keep your head out of that area, and it's just like a very simple way for like new welders to understand. Oh yeah, I shouldn't put my head there because I don't want to take it off. Same thing with fume. Like get your head out of the fume plume. I know that changing the position or repositioning your body or kind of, there's a lot of different mechanisms we can put in place to mitigate that fume or keep it out of the welder's breathing zone. But ideally, from start to finish, you want to keep your head just out of the fumes in general.
Right, but it's easier said than done.
Yeah,
That's
it's
why
hard
we
sometimes.
well, because we don't know which way the air currents are going to are going to move the fumes, and welding fumes are very sensitive to the slightest air movements as well. So in other words, if you don't have any way to direct the fumes, then it's going to be highly variable. So, and based on my studies, that without using some form of local exhaust ventilation, compared to doing the same activity, the same job site using local exhaust ventilation, there's a lot more variation in the group without local exhaust ventilation because we had no control over which direction the fumes are moving. So if we put an exhaust fan or something that we pull the fumes a certain direction away from the welder, then we're controlling the path of the contaminants, away from the welder. And the welding position plays a big role. And you bring that up, and I want to touch on this because welding down flat tends to have the highest potential for exposure because fumes are going to rise, and they will tend to rise back in
your
the
face.
welder's breathing zone. Yeah, and the lowest position will be welding in a vertical position, a vertical seam, a plate, not like a vertical seam on a pipe, but a plate where you have a substantial, number of feet that you're welding a vertical seam because the fumes are going to stay very close to the plate, to the heat effective zone. Is going to rise and stay very close to the plate, and the guys in the welder's breathing zone is not even in the path of the fumes. So typically, I don't even need local exhaust ventilation if they're purely welding in a vertical position. Now, welding in a horizontal position is very unpredictable. It's kind of like down flat. It depends on which way the air currents are moving. So you could have overexposure conditions. It depends which way the air is moving, air currents are flowing. And welding overhead, it just depends on how the fumes roll off the steel and if there's any openings for the fumes to escape. So if that's the case, if they have room for the openings for the fumes to escape, then the welder will be fine.
Right. Yeah. I mean, but if you're welding like an inside corner joint on a enclosed space or confined space or anything, you're kind of screwed at that point. It's not going up as
up.
right
where you're welding. It's gonna be pushed back down. So over time you're gonna have an overexposure. That's right.
Okay. Now, so like with large fabrication shops or like schools where a lot of welding is being done by a lot of people simultaneously. Let's talk about filtration because I know you said like at the source fume extraction is the best, and that's ideally what all schools should have. But I know that the type of filter that's being utilized has a big effect too, because not all filters are going to filter out hexavalent chromium or some of the other like really small particulate size fumes that we're exposed to. But I think it's a MERV 16 is what I was using when I was teaching. I made sure that all the filters were MERV 16. So you might have like a false sense of security if you're using a subpar filter for this type of work. So can you talk on filters a little bit?
Yeah, I mean the highest filter efficiency is a HEPA filter, which is a high efficiency particulate air. Now that has an efficiency rate of 99.97, so it's going to filter out particles on average that are 0.3 microns in size. So these are the size of welding fumes, size of below the size of asbestos particles, typically or around this size. And it's going to filter out 99.97% of those particles. So that's the type of filtration that you will be recommended in most cases. If it's if it involves asbestos, welding, I would recommend a HEPA filtration for that as well. Now, as it gets loaded, then you're gonna. I mean, it actually improves the filter efficiency as it gets loaded because
now it's
you got
got more
less
matter
but
to go through.
it takes more power to be effective. So there's more static pressure involved. Um, so, uh, but regardless, they have to be maintained regularly. I mean,
That's
if
the
they get
biggest thing
loaded,
is keeping it clean.
if they get yeah, if they get loaded up, then they're going to lose its the capture velocity is not going to be as good, because you're losing its power as it gets loaded. So they have to be regularly cleaned and maintained. Now you have different types. Filtration is the simplest ones. I mean, you have to electrostatic precipitators. That's a very high maintenance type of system as well, which the particles get attracted to plates on the inside of it, and those have to be cleaned out regularly, very frequently. So don't see them very often anymore. They were fairly popular, 20 years ago. I don't see them very much anymore. I see mostly filtration units.
Yeah, that's what we had at the school was the filtration system. So it would pull all the particulate matter into like this big box, and then that would filter out, and then go back through into like a like a discharge area. But it would trap all the particulate matter, and at the end of the day, it would self purge. So it would send like a puff of air going the opposite direction of which it was sucking all day, and it would blow all the dust and particulate matter off, all the solids, and then that would go down to like a catch basin. And like at the end of every 20 weeks or so, we could go through and change out the catch basins, just empty those, and the filters I think they pretty much lasted for about a year, which wasn't bad. I mean, it was minimal maintenance on my part. It was probably maybe 4 or 5 hours on a Friday to go through there and clean everything up, because you got to put the bunny suit on and the respirator and all that good stuff, because I don't want that crap on me. It's very, very fine, like talcum powder. But we'd bag all that up and we'd send that out for hazmat, and then put new bags in and everything and clamp everything back up, and then you'd be good to go for the remainder of the year for the most part. And then once a year we'd go through and do the capture all that particulate matter again, but then also change out all the filters.
Yeah, that's what you brought that up. As far as the especially if you're welding stainless steel and stuff, and you do have some exposure from cleaning out the filters, collecting them, bagging them up. You're going to have some dust exposure there. And that's an area that we really haven't seen much data at all on. But at the same time, let me talk a little bit more about Chrome 6 in different valence forms. Now, like I said, the chromium metal has a valence state of 0, so it does not have Chrome 6 in it. Now, there's different valence states, anywhere from -2 to +6 valence states. Now, trivalent chromium, Chrome 3, is the most stable form of chromium. Chrome 6 is the second most stable form of chromium. Now, all these other valence states are going to either be oxidized or reduced to trivalent chromium. Most of them are going to, either going to be oxidized or reduced the trivalent chromium, even Chrome 6. So after Chrome 6 is emitted, we collect a sample. We have so much time to get those samples off to the lab before they're reduced back to trivalent chromium. So there's a maximum period that they have to be analyzed from the day of collecting those samples.
Oh, wow.
Otherwise, we're going to lose the certain amount of Chrome 6 in that sample. And the same thing with the filters. So you clean it out. A substantial part of the Chrome 6 that was originally captured in a dust collection system is going to be reduced to trivalent chromium. I'm sure there's still going to be some amount of Chrome 6. I haven't seen any studies that really address that, though.
Huh. Yeah, I never would have thought of that. You would think all the Chrome 6 particles would be in there too, but I guess it's kind of like nuclear stuff where it's got like a half-life, but it's just kind of short. It just reduces itself back down to a Chrome 3.
Right.
Huh. Science. Man, this stuff's crazy. Now, when you guys, when you go out to like a shop or a facility or anything, how are you actually measuring and collecting air samples, and where are you collecting the samples from?
It's a good question. Well, it depends on the potential contaminants, but typically for a shop, either dealing with metal fumes or Chrome 6. Now, the method is essentially the same, regardless. I'm going to sample for Chrome 6 or other metals. The main difference is the lab can only analyze Chrome 6 on a single filter, cassette filter. Okay, I can analyze multiple metals on one filter, and even do a total weight, a pre-weight and a post-weight to get total fumes or total particulate exposure value as well. So I can analyze, manganese, nickel, even chromium metal, not chrome 6, but all in the same sample, arsenic, iron oxide, magnesium, all your metals essentially, elements. But for Chrome 6, they would have to collect on a separate filter. Now, how these are collected is the welder will wear a personal sampling pump. There'll be a Tygon tubing that connects the filter, and there's a right and wrong way to place that filter. So if the cassette filter falls off during the sampling, I tell the welder, hey, that happens, let me know, and I'll put it back on because there's a right and a wrong way to do it. Otherwise, the sample will be no good. I mean, if it's put on backwards, then I'm sucking air through the wrong side of the cassette filter, and so it's going through the backup pad, and it's I'm losing the sample, so that sample will no longer be good. So it is calibrated at a certain flow rate. I do a pre calibration and post sample calibration, typically at 2 liters per minute, and it's typically a duration, a full shift sample. Unless they're doing a specific task, then I'll do a task specific sample, meaning I'll start the sample at the start of the task, in the sample upon the completion of the task. Okay, and take notes, observe what they're doing, what conditions are present, what the consumable electrode that they're using, amount of Chrome 6 that may be in the wire, if that's a concern, if there's any coating on the base material, any low resolve spinellation. I document the welding position. One thing we haven't talked about is the arc time, as far as which is a huge exposure variable. The speed of the welding, the amount that someone actually welds, obviously is a large factor, and you get a higher exposures. Someone who is a production welder versus someone who's doing fit up work and tack welding, intermittent welding, or just welding for part of the time and not, doing something else the rest of the time. So you have to try to capture as much information like that and note as much information like that as well. What I do is I typically use arc timers in my studies, and I'm probably the only one I know of anyway, that routinely uses arc timers and when doing welding fume sampling. And people have a tendency to overestimate the actual arc time, but they do it by other means.
Well, especially the welder.
That's right. So typically on average, someone who's doing fit up work, tack welding, typically you're looking at like a 3% arc time. A production stick welder is typically you're looking at maybe 13% arc time, as opposed to a production welder who's doing MIG welding or flex core arc welding. That's probably more like 20%, arc time. Someone who's doing submerged arc welding or a mechanized flex core arc welding or some other mechanized mean, you're looking at more like 25, 30 plus, percent. You get setup time involved with that, but yeah. So in TIG welding, it depends. I mean, you can do, depends on the welder on TIG welding. Now, I have gotten a couple of samples that have a very high arc time. Typically, the only 2 times when that was the case, when I'm talking like 50% arc time, and that's very high as an arc time, for TIG welding.
Oh yeah,
especially. But the 2 situation was, one was a actually wire feed TIG welding apparatus, so some form of a mechanized TIG welding, and the other one was a down flat, what do you call it, the welding bead after bead. It's a
like
right, surfacing welding, but there's a term for that, and it's drawn a blank now, but it'll probably come to me in a little bit. But so arc time is a big factor, and you want to have some way to means to capture that, even if it's in a qualitative method, such as, okay, well, he's doing fit up work, or he's doing production, he's production welding, and so and it's very hard. Otherwise, it's somewhat very hard to categorize. This person's the amount they actual weld, because that is a large factor. Actually. So now back to the sampling method. There has been studies on where to put the sampling cassette. We sample inside the breathing zone. Now, typically, the breathing zone is the area, the bubble around a person's head. But when it comes to welding, because they have this welding hood on, there's been some studies in the past. Now, do you put the sample inside the hood or outside the hood? There's been some comparison studies on outside versus inside the hoods with conflicting results. One study years ago said that the inside the hood study or inside the hood samples were lower than the outside samples, and concluded that the welding helmet somewhat deflects the fumes. Another study done
That makes
Another
sense.
study done after that said that there was little difference found inside versus outside. Mike Harris, a colleague of mine, is also very experienced in welding fume exposure assessments, did a limited study and found that there was little difference in more restricted environments. And I would go along with that, meaning that if there is like welding in a confined space, there'll be less of a difference because you have more background exposure to fumes that could be impacting the inside the hood value. And I have another colleague of mine, Arlen Sear, who perhaps has the most comprehensive data as far as paired sampling data on inside versus outside of hood, and got his own study, his own results got conflicting results. Sometimes it's greater inside, sometimes it's greater outside. I've Mike Harris shared with me a video of him welding, and they use Tyndall lighting. And Tyndall lighting is a lighting effect where you can see visible particulates in conditions that you would not otherwise be able to see, such as you have a black background and you have theater lights, and you look up at the theater lights and you see in the beam of the lights you can see particles. Normally you wouldn't be able to see that, but it's on the black background. You have a beam of light, and it allows you to see these particles that under these certain lighting conditions that you would normally not be able to see. So he did it as a demonstration, did a Tyndall lighting demonstration with him welding, and you can see the fumes coming up through his mask and up through the top of his mask under those conditions. So you can see that in some conditions, it can actually be greater inside the hood than outside the hood. So what's the recommendation? Where's the best? So you get conflicting results on these studies, inside versus outside the hood sampling results. So the only thing I'm sure of is the person breathes through his nose and mouth, right? So you want the sampling collection device to be as close as possible to the nose and mouth. So I actually put a piece of duct tape, suspended in their suspension. I clip it on there, and I instruct the welder when they have the hood on, clip the cassette here, so it's fairly close, right about here. When they have the hood down, I want to make sure it's when the hood's down, that the sample is inside the hood. And when they take off the hood, and go ahead and clip it onto your collar, and then I'll come around and check on them, throughout the day on that. So we want to be careful. We want to be sure that we sample inside the hood, because that could be a rather significant difference in the result.
Yeah, it would make sense because at one point the hood and I would imagine hood design would have a big impact on that as well, because like your hood could essentially be a deflector, like you said originally, or it could actually
Yeah.
turn into a funnel. Depending on, I mean, a lot of people modify their hoods, or, everybody's got a different form or shape to it and everything. I mean, I would imagine that's got a big effect on it as well, especially when you're welding flat and that stuff's coming straight up, and the only thing you're focused on is the puddle. You're not looking at where the fumes are. That's probably, I would imagine it kind of acts like a funnel based on the shape of the hood.
Yeah, it could. Yeah, so I haven't seen any studies looking at different hood designs. I think there are some out there. I don't recall seeing reading any of those studies though. But I'm sure the hood design has an effect on it as well.
Yeah, it would make sense. That's one of the things I wanted to talk about that you had on your website is actually changing the mode of metal transfer. So if you're doing gas metal arc welding or MIG welding, and you're running short circuit or you're running, spray or anything like that, or, globular transfer, especially if you're using CO2, it's all going to emit different gases. And then switching over to like a pulse or a spray application is going to help mitigate a lot of the weld fume, because with the newer technology with like pulse and pulse on pulse, rapid pulse, all this stuff, you're freezing that puddle a lot faster, so it doesn't have time to kind of cook off all that particulate matter.
That's right. So one of the a rather large exposure factor is the amperage. Okay, so the fume generation rate is exponentially related to the amperage. As you increase your amperage, more fumes you're going to generate. So, and that relates to whether you're in short circuit or globular transfer mode or spray mode. Obviously, spray mode has the highest amperage associated with that, and so where your droplets are smaller than the diameter of the electrode, that's spray mode, right? Globular transfer mode is where the actual droplets touch the metal and transfers in that fashion. And the short circuit is when the droplets are larger than the diameter. And so short circuit has a lower fume generation rate. As the amperage increases, the fume generation rate increases. So short circuit is going to have the highest fume generation rate. Now, you mentioned the pulse MIG welding, which it pulses, so you have the metal is cooler over a longer term average, so we have a lower fume generation rate. It's in like spray mold, but it has a pulsing energy source, right? So on average, the wire is cooler, so which is important because the hotter it is, the more fumes you emit. So studies have shown that it does reduce the fumes by a pretty substantial margin.
Yeah, but I would also imagine that, like you were saying, arc time would be a big effect. So if you switch over to like a pulse or spray process versus short circuit, you're going to be traveling at a much higher speed. So you're going to have a much shorter window for exposure because you're welding a lot faster. So if you're doing, let's say a 12-inch piece, I could be done a minute or two before somebody who's, if I'm running spray or pulse compared to somebody that's running short circuit. Like I'm already done over here in a completely different area away from the hazards. And they're still, right there in the fume plume.
Yeah, and that's a good point.
Yeah, I that never even crossed my mind until I started reading through. I'm like, you got a lot of cool articles on your website.
Yeah, and there's I've done some presentations on. We also Arlen Sear and myself, we collaborated on some things, and he's done a lot of interesting studies, and he's an industrial hygienist for Exo Energy up in Denver, Colorado, but he's got a lot of experience in welding, and we co-arranged a number of welding roundtables at the American Industrial Hygiene Conference over the years. But he studied the cost comparison of different welding processes and the exposure. So comparing the exposure and in actual the costs, we compared the exposure of Chrome 6 with stick welding, MIG welding, flux core arc welding, and the costs. He's devised a way to estimate the cost of doing the same runs or same task, and compared the cost of those three. And I presented that one year, several years ago, and this was related to Chrome 6 or welding on stainless steel and Chrome 6 specifically. And obviously, I told you that stick welding typically generates the higher exposures, all else remaining equal. But it also is the more costly out of the three, compared to MIG welding and flux core arc welding. When you look at production time, how long it takes to weld the seam. So the point is, if you can use a different process for welding stainless steel than stick welding, if you're allowed to use flux core arc welding, it'll cost you less, and you have a lower exposure. You still have exposure, above the PEL likely, depending on the task and the position and stuff like that. But certainly would be less than what you would if you were stick welding the whole seam.
Yeah, so you could actually change your process and then invest in fume extraction systems or invest in additional safety measures, and that just switching the process is going to pay for the fume mitigation now, to an extent. I'm sure there's an ROI at some point. But if you switch processes, you're saving money now because you're increasing productivity, and now you can provide a safer workplace for your
that's right.
employees.
Yeah.
Or you can get a new boat, whichever.
Right. But there are some other considerations. I recognize that too. You may, the welding technical aspects of it, I'm not an expert in that. So there may be, I understand that stick welding has a higher penetration rate than flex arc welding. So you may need to weld a root pass using stick welding. So, so those are obviously considerations as well.
Yeah, it just depends on, what you can get away with as far as like your welding procedure specs and all
Right.
that, what's been tested. Yeah. Yeah, there's a lot of stuff that goes into it. Like when you were talking about how you set everything up, with all the different variables, all I can think about is like when I write a welding procedure specification, because I'm the same thing, amps, volts, wire feed speed, arc on time, gas composition. But you're doing all that and then more. You're taking in a lot of the environmental factors that go into it. So it's really cool to kind of see how all this stuff lines up.
Yeah, it's interesting to me. I mean, it's like I said, I've been doing this, pretty much my whole career, been involved with welding, and welding fume exposure assessments, and I've been there, I've done it. I'm not as a production welder, but I spend all day, in the shop, learning how to weld, and know that I just I gain an appreciation for it. So I'm using my skill set to evaluate potential exposures to welders. So, and you have to understand also the science is still evolving as far as potential health effects of welding fumes. Now, about 5 years ago, the um, International Agency for Cancer Research had designated welding as a Group 1 carcinogen. So that's something to be aware of. So that's kind of an emerging topic. And as far as that designation, they classify welding fumes as something that causes cancer, or at least potentially can cause cancer. Also, there's some information that indicates that it can cause, there's some kidney effects, kidney cancer associated with it, ocular melanoma from the UV radiation. So it's not just strictly to pertaining to welding fumes, but a large part of it. Now, iron oxide, which is the primary constituent in carbon steel, has been known to produce a benign condition called siderosis, which is a darkening of the lung. Not directly implicated by as a cause of lung cancer, although more recently it's been alluded that iron oxide may be playing a larger role in the risk of lung cancer, and it doesn't directly cause lung cancer, but it introduces additional free radicals in your body, which indirectly it could contribute to the risk of lung cancer. So that's something that's relatively new, a new emerging topic or belief. And iron oxide is that, and manganese. But iron oxide, you have more iron oxide in carbon steel than you do manganese. It's just that manganese has such a low TLV that it's what we try to control. But if you control for manganese, of course, you can control for everything else, unless you have some type of coating on the steel.
Okay, so I mean, ideally, as a welder, like in this industry, you want to protect yourself, especially if the employer's not doing that for you. So if they don't have mechanical means set up to extract the fumes, you should be using a respirator or a PAPR system, or something to mitigate the fumes, so you're not breathing that stuff in all day. Regardless, like anything that you burn, I mean, sitting around the campfire is probably not good for your lungs. Like anything you burn and inhale, anything other than oxygen and nitrogen, the stuff we're supposed to breathe in regularly, that's you want to try to prevent that from going inside your body. So the best thing you can do is like I said, respirator or PAPR system or some sort of fume mitigation, just to stay away from it. Keep your head out of the fume plume and protect yourself, because at the end of the day, you're the only one that's really concerned about your own safety. I mean, the company is. I mean, some of them genuinely care. Some of them, it's just a big expense, if they get hit by OSHA or, workman's comp or anything. But at the end of the day, like, you're responsible for your own safety.
Yeah, that's good. That's a good point. Now, and like I said, even if the company doesn't have a, elaborate, fume extraction system or portable, fume extractors. I mean, like I said, you can use a fan and turn it the opposite way and put it next to where you're welding. It may not be, it depends on the configuration, of course, what you're welding. You may not be able to do that in all situations, but but that would be something you want to look at, and anyone can come up with a solution. As far as there's usually fans in the shop, that you can, pull up and turn it around in exhaust configuration. So, and then obviously, if there's a respirator should be available as supplemental protection.
Yeah, definitely. I know a lot of companies that I've talked to, especially the larger ones, they're starting to outfit their employees with PAPR systems.
Yeah.
Just because the amount of, it's just more feasible that way because, like you said, depending on the configuration of what you're welding on, at source fume extractions, it might not be feasible. The arms can only go so far, they can only collect so much. So the best way to protect the employees is through a PAPR system. And then, they have other local exhaust, because everything kind of goes up in the air. But like right where the welder is, because they're moving around so much, that's pretty much what they've switched over to is PAPR systems.
Yeah, so there's two types of ventilations. There's local exhaust ventilation, which is capturing the contaminants at the source, and there's general dilution ventilation, which is your building ventilation. You're building the natural ventilation, the exhaust fans in the building system. So, that's probably the least effective means. It is a factor, but it's not a huge factor as far as exposure, because for the fumes to get to the building exhaust system, to be exhausted out of the building, they usually have to pass through the breathing zone of people. So it's not going to really eliminate or reduce exposure all that much. So it's not a huge exposure factor I normally look at when I do studies.
Yeah,
I'm looking at
that kind of falls under the
I'm looking at fumes that's near the worker, and looking at how they're behaving. Are they passing through the breathing zone, or are they being extracted or moved, pulled away from his breathing zone?
Okay. Well, Jerome, it's been a pleasure having you on the podcast today, man. I really appreciate you taking your time out of your day to come on here and kind of educate us on permissible exposure limits and hexavalent chromium and, just different factors that we are exposed to as a welder and kind of how to mitigate some of those risks.
Yeah, no, I appreciate you inviting me. And like I said, I've done a number of presentations like this before. I can do it, webinar style. If you have any of your audience members that are, wanting more information, knowledge on this topic, I can certainly, do a session, either on your podcast or someone else's, webinar, audience or something like that. I'm willing to do that.
Yeah, we could definitely set that up.
Sure. So yeah, we'll appreciate it. And anyway, it's good talking to you.
You as well.
All right.
All right, ladies and gentlemen, as always, thank you for listening to the show. I really appreciate it. I hope you all enjoyed the conversation with Jerome and I, and that you walk away with some information on how to protect yourself out there while you're welding. Hope you all have a great rest of your week. Stay safe out there, and until next time, make every weld better than your last.